Welcome to our notes on graphing systems of linear inequalities. Students will be able to graph a system of linear inequalities on a coordinate plane. A system of linear inequalities means that you are going to graph two linear inequalities on the same graph, and then the overlapping shaded parts is the actual solution to the system. So for number one, I'm going to graph this system. So first I'm going to graph y is less than -4 in blue. And then I'm going to graph x is greater than 3 in this coral color. Okay, so watch carefully. I highly recommend that you put your pencil down. I'm going to shade in two different colors here just to show you. So first, y is less than -4 means all points that are below y is -4 is a solution to just that inequality. Now, I'm going to look at all points where x is greater than 3. So that means everywhere to the right of 3. And this overlapping part right here, I'm going to change the color, maybe do something a little bit darker. This overlapping part is actually where the real solutions are, okay? It has to be overlapping. So nothing in here is actually a solution to the system over here, because it's only a solution for x is greater than 3, but it is not a solution for y is less than -4. Okay, and same thing down here. This, all of these points only satisfy the first inequality, but does not satisfy the second. Only this region right here satisfies both. All right, so here's a slightly more challenging example. Here we have an inequality written in standard form as well as an inequality written in slope-intercept. So you have to be very familiar with this. So the first inequality is actually written in standard form. So we actually have to find the intercepts. I actually found them here. You can do the work on a separate sheet of paper if you need to, but you must find those two. So once we have that, let's go ahead and plot them. So here, 0, -1, 3, 0. This slope is actually easy to find. If I just look at the pattern, I go up 1 and right 3. So I'm going to do that. I'm going to continue doing that so that I can graph this quicker. Okay, and then you'll take your ruler and you will go through all the points. So I got to move this around because I'm on a computer. Can't really use a ruler, but that's okay. Okay, so, and it will be a solid line because it says greater than or equal to. Now I'm going to take a different color and I'm going to look at the second one. Y is less than 2x minus 6. So that means the y-intercept is 0, -6. And then the 2 in front of the x means I go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay, so you do have to remember how to graph these. Okay, and then this is going to be dashed. So I like to do as many of these dots as possible just so that I don't lose my way. All right, now comes the shading part. You want to shade very, very lightly for each of these because remember, you have to look for the overlapping parts and make sure that that is the darkest part. So if you use the test point 0, 0, which is my favorite one, since 0, 0 is not on either of the boundary lines, it's a really good point to choose. Okay, otherwise look at them individually and figure out which test point you want to use. So if I plug in 0, 0 into the first inequality here, it produces a false statement. 0 is not greater than or equal to 3. That means I'm going to take blue and I'm going to shade below because it produced false. 0, 0 was above that blue line, so I have to shade below. Okay, now I plug 0, 0 into the second inequality, and it also produces a false statement. 0 is not less than -6. So since 0, 0 is currently above this coral line, I'm going to shade below. So I'm just going to change the orientation here, and then the part that's overlapping that has both the blue and the coral, is actually my solution. So I'm just going to take this gray here and I'm just going to kind of shade it in. I highly encourage that you do everything super light and that you definitely don't use highlighter or pen when you do this. Okay, just in case you mess up, you have to erase it and try again. Okay, so here we have two questions. Part C says, does the point 0, -3 satisfy the system of inequalities? Well, in order to satisfy a system of inequalities, it has to appear in the overlapping region. Here's 0, -3, and since it does not appear in the overlapping region here, it is not a point that satisfies the system. In fact, it only satisfies this inequality 1x minus 3y is greater than or equal to 3 because that's the blue line that I drew. So the way that we write that is 0, -3 does not satisfy the system of inequalities because it is not in the overlapping region. And you can be even more specific by saying it only satisfies the first inequality but not the second. Okay, it has to satisfy both to be a solution. Okay, and then part D says, find a point that satisfies the system of inequalities. Well, you have an infinite amount of answers that you can give as long as it appears in this shaded region. Now know that this x axis and this y axis can extend all the way to positive infinity here and negative infinity here. So you can even go off the graph and still be correct. But for simplicity, why don't you pick something that you can actually see on the graph? So for example, any point in that overlapping region works. So 6, -2, which is right here, that works because it's in the overlapping region. 8, 0 works. 10, -10 works. Okay, and I can even do like 20, -20. It will be way out there, but I don't really have that much space to show you that, but even that will be a solution. All right, so here is a problem that I want you to try. Whatever work you need to do in order to graph these is what you need to do. Remember, if you have standard form, you want to find the x and the y intercepts. And if you have slope-intercept form, you want to identify the slope and the y-intercept and go accordingly. Then answer if the point 9, 2 satisfies the system of inequalities and explain. And part D says find a point or maybe another point that satisfies the system of inequalities.